All right, welcome. Today we're going to take what looks like a messy, tangled pile of equations and turn it into something clean, powerful, and honestly pretty cool. We are going to demystify the matrix.
So, let's kick things off with something you've probably seen 100 times. A system of equations like this. Two equations, two variables, you know the drill. You can use substitution or elimination, and either way, you can totally handle it.
But what about this beast? All of a sudden, we've got four equations, four variables, and trying to keep track of everything becomes a total nightmare. It's just chaos. I mean, come on. There has to be a better way to handle this.
And guess what? There is. The tool we use is called a matrix, and you can pretty much think of it like a spreadsheet for our equations. It's how we bring some serious order to all that chaos. So let's dive in. You know, the idea at the heart of this is actually super simple. All we're going to do is strip away the variables, the x's, the y's, all the letters and plus signs, and just focus on the numbers themselves. We just arrange them in a nice, neat grid.
Okay, so before we can start building these things, we gotta learn the language, right? There are two main types of matrices we're gonna need to know when we're solving systems of equations.
And this slide really nails the difference. Over on the left, you've got the coefficient matrix. It's exactly what it sounds like, just the coefficients, the numbers touching the variables. But look at the right. The augmented matrix adds that one extra piece of info. You see that vertical bar? It separates the coefficients from the constants, the numbers on the other side of the equal sign. That's the one we're going to be building. Now, here's a really quick but super important detail: how we talk about the size of a matrix. The rule is always rows first, then columns. Always. A good way to remember it is just think height, then width. So a 3x4 matrix, like you see here, is 3 rows tall and 4 columns wide. Simple as that.
All right, enough theory. The absolute best way to get this stuff is to just do it. So let's get our hands dirty. We're going to walk through 3 examples and turn these equation systems into augmented matrices right now.
We'll start with that easy one from the beginning. First thing you do is just look at each equation and pull out the numbers. So for that first one, 2x plus 3y equals 7, our numbers are 2, 3, and 7. And boom, there it is. The numbers from the first equation make up the first row. The numbers from the second equation make up the second row. Oh, and notice that x in the second equation? It has a secret coefficient of 1, so we put a 1 in its spot. So clean, so simple. Okay, time to level up. A slightly bigger system now with 3 variables, x, y, and z. But hey, don't let the extra variable fool you. The process is exactly, and I mean exactly, the same. And just like that, here's our matrix. Every equation gets its own row. But now, look, each variable gets its own dedicated column. The first column is for all the x's, the second for the y's, and the third for the z's. It's all about that perfect, consistent alignment. Okay, now for the classic curveball. This is where people usually get stuck. If you look closely, that first equation is missing a y term, the second one's missing an x, and the third is missing a z. So what do we do? Well, there's a really simple, elegant rule for this. So here's the secret. A missing variable isn't really missing. It's just hiding. It means its coefficient is 0. So the most important step here is to actually rewrite the equation and put in that 0 as a placeholder before you even think about building the matrix. And check out what happens when we do that. By putting in those zeros, we make sure every column stays perfectly lined up. First column is for x, second for y, third for z. No gaps, no shifting around. This right here is the absolute key to keeping bigger systems organized. Okay, so now that you know how to build them, let's talk about how not to break them. We're going to go over the 3 most common mistakes so you can sidestep them completely. We literally just talked about this, but I'm saying it again because it is hands down the #1 mistake people make. If you forget that 0, your whole matrix gets thrown off and it becomes impossible to solve. So just burn this into your brain. Every variable gets a column, period. If it's not in the equation, its coefficient is 0. No empty spots in the matrix, ever. Now, this might sound kind of basic, but it's so important to get this habit down right from the start. Just think, rows are your equations going across horizontally. Columns are for your variables, stacked up vertically. Keep that straight, and you're golden. And the last trap, make sure your variables are in the same order in every single equation before you start writing anything down. If your first row is set up as x, y, z, then your second and third rows have to be x, y, z too.
If you mix up the order, your columns are basically meaningless.
So, I know what you might be thinking. Why are we doing this? Is this just some weird abstract math thing? And the answer is a huge no. Turns out matrices are basically the language used to solve some of the biggest, most complex problems out there in the real world.
So, take a look at these dimensions, 20 by 21. What on earth could that be? It's not just a random size. It's the size of a really important matrix. Believe it or not, that's the size of the matrix a traffic engineer uses to model the flow of cars through just 20 city intersections. That's a system with 20 equations and 20 variables. Could you imagine trying to solve that by hand? No way. But for a computer, which is built to handle matrices, it's a piece of cake. This is literally how they figure out traffic light patterns. And that really gets you thinking, right? From creating the amazing 3D graphics in video games to powering the AI on your phone, matrices are the fundamental tool we use to translate our complex world into a language that computers can actually understand, analyze, and solve. And it all starts with this simple, organized grid of numbers.